Okay, this is part 3 of lesson 8.2 on component vectors. Now we're going to use vectors in word problems, specifically speed and distance problems. These are where they're most applicable, although there are other applications. Let's look at problem 3 here, which is a little more complex than the other two. An orca whale is swimming at a speed of 30 miles per hour toward an island 120 miles due east. There is a current running at 5 miles per hour due south. So what is the whale's effective speed with the current? So what we're talking about, we know that the whale is moving in this direction. He's moving east at 30 miles per hour. It's the magnitude. But then we have this current pushing on him at 5 miles per hour. We want to know what's his speed, her speed. Essentially, we want to know that. Okay? So it's simply just a Pythagorean theorem problem where we can take 30 squared plus 5 squared, take the square root of that sum. And if we do that, we get 30.41 miles per hour is the effective speed of that whale, because that current is always pushing on them, and it's going to actually give it a little bit of a boost, but it is going to push it in that direction. And then the next part of the question says, if we change our vectors to distance, how many miles must the orca travel to make up for the current? Hint, the current acts on the whale for more than an hour. So again, we are still going to have our same triangle here. It's just now instead of the whale, instead of 30 miles per hour, well, the whale's trying to get to an island that is 120 miles this way, but it is being pushed in this direction by the current, and that current is going to be $25 miles. It's going to push it. Just realize that's the missing component here. So then what would this be? Well, again, we could do our Pythagorean theorem, and we would find that this is 122 miles. It's going to push it out of the way. So that's what this whale actually has to go, is 122 miles. And then the time would be 122 miles divided by the speed it was going at from the previous problem, 30.41. It's going to be about 4 hours, just a tad over 4 hours, but about 4 hours. Okay, let's look at some easier ones here. A jet leaves Los Angeles traveling due east at 300 miles per hour. Hits a headwind of 25 miles per hour. Headwind means it's pushing against it. This is just a simple vector subtraction problem. So the effective speed of the plane is going to be 275 miles per hour. Last problem. A boat is crossing a river at a speed of 10 knots. Hits a current of 2 knots. We want to know what is its effective speed. 10 squared plus 2 squared. Square root of that is going to equal, let's see, we've got 10 squared is 100 plus 4. Take the square root of 104, and we get about 10.198 knots. And that is the speed that it's traveling at. Okay?